Hello friends, welcome to TechnoBytes. In this video, we will learn about Kotlin Coroutines. So if you have been working in the Android for a while and you have been using Kotlin language for your application, then I believe you must have heard the concept about coroutines. Coroutines are basically a concurrency design pattern made to execute asynchronous tasks in a separate thread. If you have to perform some heavy operation like making a network call or getting some data from a file or making some heavy calculation, then we can use coroutines for that, and they are very fantastic to use. If you are using Kotlin, then you some of you might have also used it. I started my Android developer journey in a Java language, and later when Google has announced that Kotlin will be now preferred language for Android development, I started switch to Kotlin and started learning about everything in the Kotlin language. So there was one of the topic, the coroutines. It is one of the important topic because it helps us to make a network call and make a heavy operation. And I had a lot of confusions and lot of doubts regarding these coroutines. So I slowly learned that from different sources. Then I started implementing the coroutines in my application, but I didn't had the right idea how to use which coroutine. There are different scopes of coroutines, how to handle the exceptions of coroutine, and various other things that I didn't had an idea. I was just using like everyone, someone else is using, and grabbing information from a lot of sources took a lot of time of me. So and I don't want you to waste your time on these things. So I'm creating a separate series for this coroutine topic, which will cover most of the things about coroutines, which will help you to understand better and implement it better in your application. Before moving directly towards coroutine, we should first understand what is thread. So basically thread, we can say, at a lightweight process. When one process gets some work, the work is divided into different threads, and it's actually thread defines the context in which the following instruction will be executed. Let's say we have here two threads, thread 1 and thread 2, and both are working on the same function. So there might be a chances that sequential function, the thread 1 which is executing, so thread 1 is near about to finish that function and currently working at the last line, but at the same time thread 2 might be at the second line. So that might create some discrepancy and might produce undesired output. Well, if the threads are is causing such a problem, then why to use thread for in our Android application? Well, when Android application is executing some function which I have written, it also has to do another task, that is updating the UI, and that is done on main thread. Android application by default run on a single thread, that is a main thread, and the main thread has a specific dedicated work of updating the UI each every now and then, and simultaneously it executes our function. But if we have provided some heavy function like we have to load some data from network, and we have make that call in the main thread itself, then what will happen? The main thread will be halt until we get the data, and this will freeze the UI and user will not be able to interact with our application. So this will be a very bad impression and also some hang like behavior in our application. So for this problem, thread can be a solution. We can just offload the data, offload the whatever the big complex task we have to perform, like making a network call to another thread, and the main thread will be free to update the UI consistently. And whenever the thread comes up with the updated data, it goes and the main thread can directly update the UI. Well, that is about thread. But thread has some major disadvantages, like it consumes some resources and preemption is not possible, context switching is not possible in threads. That's why coroutines have been introduced. So what are coroutines? Basically, coroutine is a concurrency design pattern which made to simplify the code that executes concurrently. As just I have said, it is a separate mechanism made to execute asynchronous calls. Basically, we can refer it as directly a lightweight thread because it consumes lesser resources than thread and it resides within the thread. So there are some differences between thread and coroutine. That is, I just I have talked that it is same as thread, but coroutines works inside the threads. There can be multiple coroutines that can work inside a thread, and another one is suspendable. So threads can be suspended whenever we want and it can be resumed at any time according to our required behavior. And later able to switch the context, like if there are different contexts like IO context, default context or main context, so context switching is possible in coroutines very easily. So let us see the graphical implementation, how is the coroutine and every process works. So this is a logical overview of coroutines. Basically this is a one big, like consider as a big factory as a process, and these two are modules, different modules in that factory, that thread 1 and thread 2. We can consider this factory as a process, and inside this these two units are thread 1 and thread 2. Let's consider, and all of these employees who are working here can be referred to as coroutines, because coroutines reside inside the thread. Both have their coroutines or both have their resources, and also the coroutines are suspendable. Let's say of these 4 workers and 3 workers here, some workers need some break, so they can take a break and other can continue. Basically coroutines, every individual coroutine in the thread can read separately. So, and it won't affect overall work. Like if there is one coroutine is not running, the thread will be continued to run. But if all the workers here, all the coroutines here are suspended, then the thread will be called as sleeping. The another advantage is that context switching. So basically these two units, consider these two separate units as different context. This is a separate different context, and this thread 2 is a different context. And if here we have to change the context of one coroutine to another, then we can easily do so. So this worker can easily go to this second thread and can switch the context and work there. So that is one of the most important advantage that is provided by coroutine. Well, that's all I had for the first introduction video of Kotlin coroutines. In the further videos we will be going to the practical implementation of how the coroutine works and to see it by running it on Android Studio. So if this video has helped you, then please don't hesitate to like, subscribe and share with your friends. Thank you so much.